and very hardworking, very, very diligent. Although he's just doing a coursework master's program, so it's not really in field or PhD, but then he did very hard work. So after the site visit that he had to Patrick Terminal earlier this year, I think it was around May.
Yeah.
So after May, he has done lots of progress. So he has developed actually a very detailed simulation model, and they're still, we are in
development.
Yes, so it's still in development. So let's just give a brief introduction to Rasyid. So Rasyid has done his bachelor's degree, University of Kyoto, Japan, and he finished in 2017. And then he worked for over 5 years in industry. Then he joined UNSW as a master's student 2 years ago. Yes, and after finishing his master's, also he's planning to get back to industry.
Yep.
But then I'm still hoping that he comes back for a PhD. That's the plan. Fingers crossed. So thank you so much, online audience. I can see that we have a couple of online attendees and also students and Professor McNeil. Thanks for coming in person as well. Very welcome to our city seminar. Please just mute yourself, but then feel free to ask your questions in the Q&A, in the chat box. We don't have a Q&A chat box. And after Rasyid's presentation, we're gonna have Q&A and discussions. And without further ado, I hand it over to you. Thanks,
Rasyid. Good day, everyone. First of all, thank you very much for coming to this seminar, for both in person and also people joining online. It's really an honor for me to be here in front of you to present my master thesis that I've been working on for the last 1 year and still working on it right now. So my thesis topic is about developing an agent-based simulation model that will be used to actually simulate several policy scenarios and analyze the impact of that scenarios on the performance of the container terminal. So my presentation will be divided into 2 main parts. The first part will be about my simulation model, and I will explain about the agents and how the agents interact with each other, and also about the interface of the model. And the second part will be about the scenario simulations that I perform using the model that I developed. So I developed an agent-based simulation model, which is one of the modeling approach where the focus here is that each decision-making players in a system is modeled individually as an autonomous agent. So each individual agent has its own behavior, has its own or the attributes that is unique with other agent, and each agent is actually capable of interacting with other agents of the same type, and also other agents of different types, and also capable of interacting with the environment. And from this interaction between agents can actually impact the performance of the overall system. And the case study of my thesis is Patrick Autostrade Terminal in Port Botany, Australia. And I developed the model using analogic software, University Researcher Editions. And this is the map of the layout of my case study, which in general divided into 3 main areas. The first is the quayside, where the vessels are berthed, and also where the quay cranes or the cranes are located. The quay crane is actually basically loading and unloading the containers from the vessels. On the other sides of the terminal, there is this landside area where the trucks are parked. This landside area where the trucks are parked, and the containers from the trucks are loaded or unloaded from the trucks, trailers. And the largest area in the terminal is usually the yard, where the containers are stored. And to transfer the containers between the quayside and the yard, and also between the landside and the yard, the stevedores, the terminal operators, has his own straddle carriers. So the serial carriage is transporting the containers and also capable of loading and unloading the containers to and from the trucks, and also storing or retrieving the containers from the yard. Before moving on into more detail, I have uploaded my model to an analogy cloud. So when you scan those QR code or you type that URL into your browser, you will be able to see the simulation in the analogy cloud. But there is some caveat here. The interface that I developed is actually not really the same as the one in this QR code, because the interface in the analogy cloud is actually fixed by the developer, by Analogic. So I cannot really make a lot of change to the interface. But other than that, the simulation model is still the same as the one that I developed. So when you open that QR code, you will be able to see this page in the analogy cloud. And when you play that display button, you will be able to see the simulations. Sorry, it's a bit slow at the beginning. Yeah, this is the simulation model. You can see here the truck is coming to the terminal, and the yellow stuff here is the straddle carriers moving around the yard, picking up the containers from the trucks, and also picking up the container from the key cranes. And you can also switch to the statistic dashboards, which show the 6 indicators that I use to measure the performance of the terminal. And it is a real-time statistic. So when you can also speed up the simulation and see the statistic is actually coming, I hope. Yeah, something like this. At the end of the simulation, it's 24-hour simulation period. At the end of the simulation, you will be able to see how the performance of the terminal in 1 hour basis is shown in these 6 charts. Okay. So as I mentioned before, the key properties of this agent base is actually the agents itself. So in my model, I use 7 different agents as shown in the slide. And the first agent is the truck, or the external trucks, or the drayage truck. Is basically the trucks that arrive to the terminal to deliver the container or to pick up the container. The trucks have 5 different attributes that is unique for each truck. The ID is the unique ID for each truck. The time slot type is mentioning whether the truck is bringing import container, picking up import container, or the truck is picking up export container from the terminal or delivering export container to the terminal for further loading to the vessels. And also, it also differentiates whether the trucks is A double trucks, B double trucks, or rigid 20-foot trucks, or a semi-trailer trucks. And the fourth attribute is the TEUs, which is the container volume to be loaded and unloaded from the trucks. And the last attribute is backloaded, which is a Boolean attribute showing whether the truck is performing backloading operation or not. I will explain about backloading operation later on in the second part of my presentation. So this is the 5 trucks type that I consider. So it is differentiated by how many TEUs actually capable that how many TEUs a truck can bring. Let's say A double is capable of bringing up to 4 TEUs. B double is up to 3 TEUs. Rigid 20 is only up to 1 TEUs, while semi-trailer and side loader is up to 2 TEUs. And this is the general logic movement of the trucks. So the trucks will arrive at the gate, arrive at the terminal premise, and then reach the in-gates. Reach the in-gates here, which is the entry point of the terminal. After the trucks reach the in-gates, it will be parked in one of the parking area in the trucks. Here there are 2 types of parking area. I call it main parking and also additional parking. So the straddle carriers can only service the trucks in the main parking area here. Here. So the trucks cannot actually reach the additional parking area. So for that reason, the trucks will be prioritized to occupy the main parking area. And then if all spots in the main parking area are occupied, then the trucks will be allocated a spot in the additional parking area. And then once there is a empty spot in the main parking area, the truck in the additional parking spot will make a reverse movement to the main parking area, so it can be served by the straddle carriers. Once the straddle carriers complete its job, if the truck is loaded with the container, then the container will move to the weight bridge to measure the weight of the container. If it is empty loaded, the trucks will go straight to the out gates. And this is the more complicated logic of the trucks. As you can see here, it will be started by the trucks arriving at the node nearby the terminal in gates, and the trucks will check if there are already a queue in the in gate. If there are already a queue, then the trucks will be automatically placed at the back of the queue. If there is no queue, then the trucks will scan whether there is an empty in gates. In gates is the entry points to the terminal. If there is an empty in gates, then the truck will move to the empty in gates, and it will interact with the in-gate agent. So the arrival of the trucks at the in-gate agent will trigger the trucks to find an empty parking spot inside the terminal. If the in-gate agent finds an empty parking spot, it will send a message to the truck, hey, this is your parking spot, you should go there. And then the trucks will automatically move to that parking spot. Once the truck arrives at the main parking spot, it will send a job request for the straddle carriers. Hey, straddle carriers, please pick up my containers, or please bring a containers to me, something like that. And then the straddle carriers will do the job. After the straddle carriers complete its job, it will inform the trucks, I have completed my job, which will trigger the trucks to move to the waste bridge if it is loaded with the container. If it is empty, then the truck goes directly to the out gate. So I mentioned before that the trucks send a job request to the straddle carriers. So basically there are two types of job submitted by the trucks, which I call it a truck-related jobs. So it depends on the time slot type that the trucks has. Let's say the truck is actually bringing export containers. So the trucks will request the straddle carriers to pick up the export container from the trucks and then store it at the yard. On the other hand, if the trucks will pick up an import container from the terminal, then the truck will request the straddle carriers to pick up an import container from the yard, bringing to the landside and then load it on the trucks. And the second agent is in-gate agents. I think I've mentioned about it before. The main role of the in-gate agent is actually finding a spot in the parking area so that the trucks can move inside the container and occupy that spot. The third agent is the vessels agent. So there are 4 berths in my case study in Patrick. So there are up to 4 vessels that can berth at the same time. So I'm assuming in my model that each vessel is served by 2 different quay cranes. And the number of containers to be loaded and unloaded to and from the vessel is distributed equally to its quay cranes. Let's say a vessel wants to load 100 export containers to the vessel. So then each QC has 50 import containers to be performed, and then another QC has 50 import containers. And once the vessel distributes the workload to its vessel, then quay crane will perform its job. So basically, I am assuming that the quay crane has a single cycle mode, which means that the quay crane will first unload all import containers from the vessels. After that, it will start with loading the export container to the vessels. So for example here, if we have the quay cranes unloading import container, it will be initiated by the quay cranes picking up import container from the vessels and then dropping at the what I call it a quayside buffer area next to the quay cranes. And after the quay cranes drop that container, it will send a job request to the straddle carriers. Hey, straddle carriers, I've dropped this import container. Can you please bring it to the yard? Something like that. And for loading the export container, it will be started by the quay cranes sending a job request to the straddle carriers. Hey, straddle carriers, I need to load this export container to the vessels. Can you retrieve it from the yard and bring it to the buffer area so I can load it to the vessel, something like that. So as I mentioned before, it's similar to the truck. The quay cranes have two types of job. It's import container job. So the straddle carriers has to pick up containers from the buffer point and then store the containers at the yard because it's import container. And then later on, this import container will be loaded to the trucks for delivery to the hinterland. And the second jobs by the quay cranes is the export container jobs, where the quay crane requests the straddle carriers to retrieve export container from the yard and then drop it at the quayside buffer point nearby the quay crane so that the quay crane can load that export container to the vessels. The fifth, I believe, agent is the straddle carrier. So the straddle carriers have these four attributes: the unique ID and the number of 20-foot containers. So one straddle carrier can handle up to 2 TEUs, meaning like either one 20-foot container or two maximum 20-foot container, or only one 40-foot container. And also the last attributes for the straddle carriers is the job type, whether the straddle carrier is performing truck related jobs or QC related jobs, which I have explained previously. This is the logic of the straddle carriers. It's basically differentiated by the job type. If the SC is performing truck related jobs with export container, meaning that the SC is requested to unload the export container from the trucks, then the SC will start its movement by approaching the truck, picking up the container and then transport it to the yard. And if the SC, for example, is performing QC related jobs with export container, then the SC will start its movement by moving to the yard, picking up export container and then transport it to the quay cranes, something like that. And I mentioned before that the quay cranes and the trucks are submitting job requests for the straddle carriers. So basically what they do is sending a job to, I create a job list for the straddle carriers. So trucks and quay cranes can send a job to that job list. And then this central control agent is actually distributing all the jobs, each job in that job list to individual straddle carriers. So by default, the central control agent distribute the work in first come first served basis. So the first job coming to the work list will be allocated first to the straddle carriers. And that's all the six agents that I create in my model. And to measure the performance of the container terminal, I measure 6 indicators here covering all those 3 operation area, the landside, yard, and quayside. We have the truck turnaround time, which measure the time spent by the truck inside the container. So it is initiated by the trucks arriving at the in gate until the truck reaches the out gate. And also the container turnaround time is basically the truck turnaround time divided by how many containers are handled from the truck. And also the queue time at the gate is actually how long the truck is queuing outside the in gate. For the yard performance, I measured the straddle carriers idle rate, which actually measure the proportion of time the straddle carrier is in idle mode, doesn't perform any job. And also the second performance is the hourly container volume processed by straddle carriers, is actually measuring how many TEUs are handled by straddle carriers in 1 hour. And the last indicator is the quayside performance, where I measured the average crane rate, which actually measuring how many containers are handled by containers, how many containers are handled by the crane in 1 hour durations. This is the user interface of my model, and we have two scenarios at the top, priority and no priority and truck priority, which I will explain in my second part. And in the last few days, I added a new features here about the truck rifle. I think it's better to me to show it in the software. Yeah, this is the user interface. So I added a new feature in the last few days about the truck arrival. So by default, the truck arrival is based on the historical inter-arrival data. But right now, the user can also simulate the truck using number of arrival per hour or per window duration. So by default, the window duration is 60 minutes or 1 hour. We can also change the window duration to 30 minutes, let's say. And then here is the number of slots offered per each window durations. According to the Port Botany landside indicator, the minimum slots offered is 54 slots per hour. We can also change, let's say, 100 slot here. And here is how many percentage of the slots are actually used by the trucks. If it is 100, then meaning that all 100 slots are actually used by the trucks. You can say because it's the morning, probably not 100, 80, and also in the evenings, probably not 100, let's say 70. We can also change the number of how many serial carriers are used in the terminal. Let's reduce it to 40, for example, and then we can run the model here. You can fast forward and then see the statistic as well here. At the end of the simulation, we will be able to see the dashboard showing the result of the 6 metrics that I used to measure the terminal performance. Okay, that's the first part of my simulation. After I develop all the features and all the agents in my model, I simulate a scenario which represents the cooperation mechanism among freight actors, is specifically the horizontal cooperation among freight actors. So there are two scenarios that I perform here. The first is utilizing multi-trailer trucks. The idea here is to bundle several shipments together and then use that bundled shipment, transport that bundled shipment into higher capacity trucks such as A double or B double, rather than using several smaller trucks such as semi-trailers. And then the second scenario is the backloading operations. Backloading operation is performed when the trucks arrive at the terminal holding export container, and after that export container is unloaded in the terminal, the truck is loaded with the import container. So the trucks arriving at the terminal with export container and then leaving the terminal with import container. And this backloading operation is performed to prevent the trucks from having an empty trips, meaning like the trucks leaving the container without any load on it. So why I focus on this cooperation mechanism? So basically in the terminal, there are several freight actors that operates, such as the stevedores or the terminal operators, the road carriers or the shipping lines, and so on and so on. And one of the problems faced by these freight actors is they have some kind of inefficiency in their operations, which could lead to the increase in the logistic cost of delivering the container. So in the existing literature, a cooperation mechanism is one of the solutions to actually address that inefficiency issues. Several studies have shown that cooperation mechanism actually brings some benefits to the freight actors, as shown in this slide. However, most of the research about the cooperation mechanism are mainly focused on these three research areas, while there is only a limited research which focus on analyzing the impact of this cooperation mechanism on the container terminal performance. Why it is important to actually analyzing the impact of cooperation mechanism on terminal performance? Let's say I'll use the multi-trailer trucks as an example. So if we have more multi-trailer trucks coming to the terminal, multi-trailer truck is most probably have more than one containers on it. So it will take longer time to process multi-trailer trucks compared to a single trailer trucks, because multi-trailer trucks have more containers on it. So assuming that we have a lot of multi-trailer trucks coming to the port, then the time required to process that container are actually longer than if we have a low number of multi-trailer trucks. And because the time required to handle one multi-trailer truck are actually longer, it can possibly affect the turnaround time of the terminal, which is not good. So this scenario is actually focused on analyzing the impact of increasing number of multi-trailer trucks and backloaded trucks on the performance of the terminal. And then I also impose a truck prioritization strategy to handle this increasing workload because of increasing number of multi-trailers and backloaded trucks. So what is the truck prioritization scenario? Earlier, I showed this logic of the straddle carrier control agent on the right side, where the control agent just allocate the job based on the first come first serve basis, regardless of the truck job type. But in the truck prioritization scenario, I prioritize the straddle carriers to handle the truck related jobs, the jobs submitted by the trucks. Why? Because the truck turnaround time is most of the time is smaller than the vessel turnaround time. So the truck is staying in the terminal shorter than the vessel, because vessel can take hours or days. So with that reason, the truck is kind of more sensitive to any disruption happening in the terminal. So if there is something going wrong in the yard, the truck will be impacted first, and then their time in the terminal will be much longer than usual, and it will impact their delivery schedules, something like that. So this is the 6 indicators that I use, is the same as before. So to simulate the truck arrival to the terminal, I connected input data analysis, which come from the 3 months truck arrival data from September to December 2022, consisting of around 130,000 entry data. And analyzing the historical truck arrival data, I categorize the truck arrival into 4 main categories. The first 3 categories are for the weekdays categories: the morning of peak from midnight to 5 a.m., peak hours from 5 a.m. to 6 p.m., evening peak hours from 6 p.m. to midnight. And for the weekend, I don't categorize into a smaller detail because there are less truck arrival on weekend compared to weekdays. And to get the best fit distribution that simulate the truck arrival, I consider the 7 potential distribution, and then I fit this 7 distribution into the historical truck arrival data. And then for each distribution, I estimate its parameter using the MLE method, maximum likelihood estimation. And the best fit distribution that fit the truck inter-arrival data is tested using the Kolmogorov-Smirnov KS test statistic. And this is the results of the distribution fitting. As you can see here, in the morning of peak category, the log logistic distribution is the best fit distribution. And also for the other 3 categories, the log logistic is also the best fit distribution. But for each category, the parameters of the log logistic distributions is not the same. Then I perform a model validation. So I adjust the parameters in the model so that the mean truck turnaround time from the simulation match with the actual truck turnaround time reported by the terminal operator, which is around 30 minutes for September 2022 period. And the result of the validation shows that there is no significant difference between the mean truck turnaround time from the simulation and also the actual turnaround time. And based on the result of the validation, this is the parameters model that I use in my simulation model. And this is the results. So I perform the simulation 100 times to get a more robust results. So each scenarios is run for 100 times. And this is the results. The charts shows the container turnaround time, CTT, and also the truck turnaround time. As you can see, the truck turnaround time is actually increasing as the number of multi-trailer and backloaded trucks increase. But it's logical because if we have more multi-trailer trucks, the time required to process one truck is actually longer than single trailer trucks. So it's actually logical to have a longer truck turnaround time. But I think it is not a suitable indicators to measure here. The better indicator is the container turnaround time. Because actually, when we have more multi-trailer and backloaded trucks, the container turnaround time is actually lower than the condition where we have a smaller percentage of multi-trailer and backloaded trucks. So, which indicate that the increasing efficiency of handling individual container. So, and the second chart is about the idle rate of the straddle carrier. So the idle rate of the straddle carrier actually decrease as the number of multi-trailer and backloaded truck increase. So the straddle carrier are kind of busier when we have more multi-trailer and backloaded trucks. And also if we see the line with the graph with the solid line here, which indicates the truck prioritization strategy. The truck prioritization strategy actually has a lower idle rate compared to the no prioritization strategy. And the third result is about the how many the container volume processed by the straddle carriers per hour. So when we have more multi-trailer trucks or backloading trucks, the container volume processed by straddle carrier is actually decreasing. So it is interesting because in the previous slide we know that when we have more when we have more multi-trailer trucks, the straddle carrier is becoming busier than before. But it's actually processing less container than before. So it's busy, but it's not really productive, I can say. So it is because when we have multi-trailer trucks, let's say we have 4 containers on each trailer. So it may be the case that when the first container arrives at the trucks, and then let's say unloading the first 2 containers, the second containers also arrive at the trucks. But because the first container is still performing its job, the straddle carrier has to wait near the truck parking area and just doing nothing, just wait there until the first straddle carrier complete its job. So the time actually used by the second straddle carriers to waiting is occupying the time that could otherwise be used by that straddle carriers to handle additional containers. So a lot of the time, the straddle carriers are just waiting there, waiting for another straddle carriers to complete this job. And this waiting time is actually taking the time that could otherwise be used by the straddle carriers to handle other containers. And the last chart is the crane rates, which is actually showing the drawback of this truck prioritization strategy, because prioritization strategy prioritizes the straddle carriers to service the truck, meaning that there are longer delays in performing key crane related jobs. So the key crane has more idle time because their previous job has not been completed by the straddle carriers. So as you can see here, when we perform the truck prioritization strategy, the crane rate is actually lower than if we have no prioritization strategy. So in conclusion, in general, if the stakeholders has no additional measure to address for increasing number of multi-trailer and backloading operation, we will see that the container terminal performance actually declines as we have more multi-trailer and backloaded trucks. And if we implement the truck prioritization strategy, it can lead to a gentle decline in container terminal performance, and it can also prevent the steep performance drops if we, as seen in the no prioritization strategy. And that's all the presentation from me. Thank you very much.
So let's see if there's any question for Rasyid. And also the online audience. Feel free to unmute yourself and ask your questions. We have Mehrdad in the room. Yes, Mehrdad, go on.
Thank you very much. Just some quick questions. Do the ship come there on their own, or a tugboat is used?
Yeah. So because the focus is the container terminal, I don't model the truck arrival to the terminal. What I did, the ship's arrival. So the ship's arrival is just represented that when the ship arrives, it automatically shows the ship's animations in the terminal. When it leaves the terminal, those ship animation just disappear from the terminal. So it doesn't include any trucks vessel movement to the berth area.
If you categorize the vessels from the beginning, for example, the bigger container comes first, and then the vessels with let's say smaller containers, the second, maybe the performance changes. But for this case, I just want to know another question. Is there any buffer area, for example, depot the containers that haven't been loaded or loaded by the trucks? Is there any buffer area there?
The yard. Perhaps the first question, if you answer the first question for the vessels.
Yeah, there's no prioritization for the vessels, but in the simulation model here, we can adjust how many export container and import container for each vessel. Here, because there are 4 berths at the Patrick terminal, so I'm assuming there are 4 vessels at max. So here, let's say the vessel at the first berth, BD6, how many import containers and how many export containers, something, and we can play with the number here.
And also I can add that the data that Rasyid has used in his simulation model comes from the port call during that 3 months. So we got the port call data from UNSW ports, and also the arrival, the berthing at the actual berthing time. So he has not really, investigated the vessels prioritization. He has just basically used the data and then simulated database.
And
so the second question was for the
point that haven't been
transport.
Yeah.
So
Go on.
there is no for the landside area, there is no temporary storage area, because the serial carrier is picking up the containers from the truck directly, and then once it's loaded to the serial carriers, the serial carrier will directly move that containers to the yard for storage. For the vessel, yes, there is. Here, as you see, like this is the temporary storage area. We call it the buffer area. So because usually there are some times when the key cranes drop the container, and after the serial carriers pick up the container, so there is some time gap there. Yeah, so that's the buffer.
Is there any capacity for that?
Not really, because I'm assuming that for each key crane there are 2 dropping area. So let's say this is one of the key crane. So this is the first dropping area. This is the second one. So when this dropping area is occupied, then the key crane will drop here. When all the buffer areas are occupied, then the key crane will just wait until one of the spot is empty, something like that.
these parameters actually have to be kind of fine-tuned, but that's the plan that we work with Patrick and also the other
I
ones.
wanted to know the utility rate of key grains because they are a little bit expensive. So to have a utility, let's say, upper than 50%, but I don't suppose I didn't see any graph related to
The crane rate.
Yeah, the crane rate is the no for the utility rates because the indicators that I use here are based on the waterline data that the Betray published. So at that waterline data, the one of the performance measure for the seaside is the crane rate. So I just use the crane rate to measure the performance of the
and also
seaside.
we kind of validate this with crane rate data from the UNSW Port Open data. And also the track turnaround time to make sure that the simulation actually is kind of like, similar to the real world patient. Okay, so from online audience, is there any question for Rasyid? Any suggestion for improvement? If not, Professor McNeil, go on.
So I've been playing around with is what sensitive rigorous. And so one of the things that's not just acquisition of the sensitivity analysis where you vary the parameters, but it's setting up an experimental design and do global sensitivity analysis and better understand the interactions between different kinds of parameters. Do you have any sense of range interactions that, because that's one of the plus sides of agent-based simulation.
Yes.
Is those interactions, and it should be captured that you might not get, So any sense of whether that would be worth doing?
At the specific analysis of the parameters, right?
A global sensitivity.
Global.
So you set up a big experimental design with varying lots of parameters the same, and then you see whether those interactions between the parameters.
Oh, that's interesting research topic.
Yeah.
Absolutely. That could be one of the cases.
Yeah, it's actually doable with the current simulation,
Exactly.
and we can even vary all the parameters. Yeah, and then check how it affects the performance of the terminal.
Yes. That was actually the whole motivation behind the agent-based simulation, because with the agent-based simulation and all of those, the agent logic, states and actions, then even like you can, so at this point in time, you have just given a distribution, but you can even like give it a very heterogeneous even distribution. So, some, for instance, turkeys, they may have different behaviors. Some other turkeys, they may we kind of we discussed that could be for the next step, but also the interaction between these agents and the parameters. You just basically change one of these parameters at one point, and then all the other ones fix and then or perhaps a pair of parameters, and see that how the result and all of those metrics actually.
So the process model is playing with multiple parameters at the same time, because they've realized that the models are complex, and in transport, I don't think we do. I also have another question if no one else online.
Yes, go ahead. Go ahead.
So one of the things about agent-based modeling compared with I first dabbled in it 25 years ago is the interfaces are amazing, right? And so how difficult is it to move interface into a different application?
Very difficult.
Okay.
it's not as easy, at least for this one. So we have used this commercial basically software, but we have the university license for it. So it is expensive for consultants or for private companies perhaps, but because we have the university license, it's cheaper. But then the thing is, you're kind of locked in to this. So now you can't really export it. It's not like an open source Python thing that
Yeah, it's not the same kind of thing that I'd like to now take this in.
Unfortunately not, no. So there are, ups and downs. So for instance, the advantage of using this AnyLogic is that for Rasyid, it was, there was lots of resources online and also support and perhaps, and also, the user interface development. It is, yes, yeah. But for the open source, we are kind of going towards that. And I love open source software and applications. And that's the plan, ultimate plan. But it wasn't at this stage, as like Rasyid just basically did this as like one course, one of his master's courses. If he comes back for PhD, then he will develop in open source.
Yeah, because the thing is here, like we fixed the simulation model based on the layout of the Patrick's terminal. Even if we have, if we see another terminal in Port Botany, let's say DP World, it has different layout. And the trucks for the DP World, let's say, can enter the container terminal area, unlike the Patrick's here. So it's really difficult to use it for, let's say, another container terminal, unless we change the layout. But for the logic, I think like for the trucks logic, I think we can use that for other terminal. Let's say the Patrick terminal in Melbourne, I think, has the same parking configurations, so we can kind of use it again for that container terminal, but probably some small change may be needed. Yeah.
Like for instance, Patrick uses auto straddle, and so the job allocation is different. The logic is different from DP World. The other thing is auto straddles in Patrick can handle up to two 20-foot or one 40-foot. And also the stacking is different. In DP World is higher because it's not, they're not using auto straddle. So yeah, you have to kind of again fine tune it, but the logic is applies to. So I don't see any question or any hands up from the online audience. Okay, so with that, then perhaps again, please put your hands together for Rasyid. Very well done. Thank you so much for your hard work, Rasyid. It was such a productive few months, right, after the site visit that you did in May. So thank you so much for your attendance, and please tune in for the next rCITI seminars. Thank you.
Thank you.
Thanks. Bye.